Hi everyone. So now that we've talked about different special functions, now we're going to talk about how to transform them. And one of the ways that we can transform them is through shifts. When I talk about shifts, I'm talking about moving them up, down, left, and right. So it doesn't change the way that it looks, it just moves them around on the graph. So before we get started with the examples, I wanted to show you how you shift something. So if we have our general equation f of x, which is right here, right? It's not usually just f of x, but we're going to use f of x just in this case, and then I'll show you how to use it with other ones as well. Now, if I have just this equation f of x, and then I say f of x plus c, with the plus c on the outside of the parentheses, that means I move the whole graph up c units. So if c was 5, if I said f of x plus 5, then I would go up 5 units. Now, if I have f of x minus c with the minus c outside of the parentheses, instead of going up, I'm going to go down c units. Then, so that's how we go up and down. Now, to go left and right, we have to put the c on the inside of the parentheses. So if we have f of x plus c with the c on the inside of the parentheses, it goes left that many units. And then if it's f of x minus c, it goes right that many units. Make sure that you're very aware of what is considered inside parentheses and outside parentheses, okay? So now let's start going through some of the examples. For the first example, what we need to do is take this equation, this parent function, which is f of x is equal to x cubed, and we want to translate it or shift it up 1. So what I'm going to do is I'm going to look for the thing that's going to help me move something up, which is this first line right here. And so what that tells me is I have to take the equation and add c to it, or in this case, add 1 to it, because I only want to shift it up 1. But that plus 1 has to be on the outside of any version of parentheses. So my answer would end up being f of x is equal to x cubed plus 1. Now we still don't have any parentheses, but notice that the x cubed stays kind of the same, and we just tack a plus 1 onto the end. So when we go up or down, we kind of just tack that number onto the end. And this would be my answer. All right, so let's look at the second example. The second example is the same. We're going to take the parent function, but this time it's the square root of x, and this time we're going to move it right 2 units. So if I want to go right, I've got to use this line of my notes, which means that I've got to put it inside parentheses, and it's got to be minus that number, or minus 2 in this case. So what I'm going to do is I'm going to write f of x is equal to the square root of x minus 2, because I want to go right 2, close the parentheses, because in order to go left or right, you have to put it inside parentheses, and then square root the whole thing. Now let me tell you this, if obviously I added parentheses to this, you don't necessarily need to add parentheses to this as long as that 2 ends up underneath the square root. If you were moving this up or down, like let's say we wanted to go up 3 units, then I would write it as f of x equals the square root of x plus 3, with the plus 3 on the outside of the square root. So the kind of the square root acts as parentheses in this case. All right, so for the third example gives you this graph, which looks like this. Let's see. And this point right here is -1. And what we want to do is identify the parent function and write an equation for this graph. So the first thing I'm going to do is look at my key terms sheet. Again, that key term sheet is going to be a real big friend for you in this lesson. And look for a graph that looks like this. Now that parent function is y is equal to x squared. Great. But if you notice, the y is equal to x squared, the parent function graph, instead of starting at -1, it starts at 0, or that bottom point right there is at 0 instead of -1. So what that tells me is that all I did is I took that graph and I shifted it down 1 unit, right? So I know I take this equation and I go down 1. So now what we need to do is write an equation for this. And because I'm going down 1, I'm going to scroll up a little bit. I'm going to use this part where it says down C, which means that I'm going to put a -1 on the outside of the parentheses. So in this case, it would be y squared, or I'm sorry, not y squared. What am I talking about? I'd say y is equal to x squared minus 1. Once again, that -1, because I'm moving down, doesn't have to be in parentheses or anything, and it just gets tacked on to the end. All right, and then for the last example, it's asking us to actually sketch the graph of the equation, and so the equation is f of x is equal to the absolute value of x plus 1. So the first thing I'm going to do is I'm going to look at what the parent function of the absolute value of x looks like. So if you look at that key term sheet, the absolute value of x normally looks like this v, where it starts at, where the bottom part or the vertex starts at 0. Because this equation is a transformation of that or a shift of that, what I need to do is figure out what it's doing to shift, and then I can shift the parent function that way. So because this +1 is inside the absolute values, that tells me, I'm going to scroll up a little bit here, it tells me it's got to be one of these two things right here because it's inside the parentheses. Because it's +1 instead of -1, I know it's got to be this guy, which means that it's going left 1. So I know this tells me that I'm going to take the entire graph and go left 1 unit, which means, let me use a different color here, that I'm going to just shove over 1 unit or 1 point and then regraph the V. So it looks exactly the same. I mean, mine doesn't because I'm not a great artist, but it should look exactly the same. It just got shifted over 1 unit to the left. And this is how we deal with shifts in transformations.